For two-way tables, like the name suggests, you need to read the table from two different ways. So reading vertically, so going down this way, and also reading horizontally. Just like Venn diagrams, two-way tables have two sets. Constructing two-way tables can be a bit like a puzzle, and you have to fill in the gaps based on what you already know. So if my data for a two-way table says, so if I'm given the problem, students across grades 7 and 8 were asked whether they love maths. There were 140 Year 7s and 160 Year 8s. Of the 230 students who love maths, 110 are Year 8s. This tells us everything that we need to know. First, you draw up your table. You'll need 4 columns. One is for the horizontal category names of loves maths and the complement of that, which is does not love maths. The second and third columns will be one for each of the vertical categories, so I will have one column for Year 7 and one column for Year 8. And in the final column, I will have my totals. Then I will also need 4 rows. The first one is already taken up by the headings of Year 7 and Year 8. The second one here and the third one, they are going to be those horizontal categories of either loves maths or does not love maths. And in the final one, that is going to be the total there. You could swap the horizontal and the vertical around, but I'm just doing it this way because it makes most sense to me. I'm going to label these areas and then go back to the question. So when I look at this, I can see that in this box, there is going to be the Year 7s who love maths. The Year 7s who don't love maths are going to be in the orange box. The Year 8s who love maths are going to be in the purple section, and the Year 8s who do not love maths will be in the pink section. The green and the purple numbers will add together to give the total number of students who love maths, and the orange and the pink numbers will add together to give the total number of students who do not love maths. And likewise, the green and the orange will add together to give the total number of Year 7 students, and the purple and the pink will add together to give the total number of Year 8 students. Then to find the actual total number of students altogether, regardless of whether they're Year 7 or Year 8, or whether they love maths or do not love maths, we can either add going this way or going this way. Both of these calculations will give us the correct answer if the rest of the table is correct. So there are 140 Year 7s. I can see the Year 7 column, and I'll travel down that column to where it meets the total row. So I'll pop 140 in here. The next part is there are 160 Year 8s. Again, I will look in the Year 8 column, and then I will write 160 in the total of that column. Now I have everything I need for that row except for the total, so I'm going to add 140 to 160, which will give me 300. That tells me that the total number of students who were asked across grade 7 and 8 was 300. The next thing that I can see is that there are 230 students who love maths. So that means I can look in my loves maths column and go across to my total and write 230. I then know that 110 people who love maths are Year 8. So I'll look to my loves maths row again, I'll go to Year 8 and I'll put in that 110. I have color coded all of these so you can see exactly where the information is coming from. In my loves maths row, I have 2 of the 3 completed, which means that I can calculate this number of Year 7s who love maths. I have a total of 230 people who love maths altogether, and I know that 110 of those are Year 8s. So I can just take 110 away from 230, which gives me 120. So the total number of students who love maths minus the number of Year 8s who love maths, which I am given, gives me 120 Year 7s who love maths. I can now see that all of the columns have enough information for me to work out the remaining numbers. I have all the totals and all the number of students who love maths. I'm going to look at the Year 7 column. I can see that there are 140 students in total and 120 of them love maths. So if I do 140 minus that 120, that leaves me with 20 students who don't love maths. Then I have 160 Year 8s in total, and 110 of them love maths. So I will say that total of 160 minus the number of students that I know about is 110, which leaves 50. So 50 students in Year 8 do not love maths. I can work out the remaining missing number in one of 2 ways. I can either subtract the total number of people who love maths from the total number of students altogether, so that's in that total column at the end, or I can add up the total number of people who don't love maths from the 2 year levels. Either way, I should end up with 70. So I'll look across 20 plus 50 in the does not love maths row will give me 70. And if I use the total column, 330 minus the number that I know love math gives me 70. So you have now completed a two-way table. Always use the information you're given. You will be given all the information that you do need to complete the table. It may just involve using some of the numbers in combination to fill those gaps. Once you've completed a two-way table, it's likely that you will need to calculate the probabilities based on the data in your table. Just like calculating probability as you have done in the past, it does look at the number of successful outcomes over the total number of possible outcomes, but it does present it a little bit differently. It is calculating the exact same thing though. So we have probability of the event, and that equals the number of favourable over the number in the universal set. Now, this does tend to be written. If you've seen the Venn diagrams video, you'll have an idea that this figure right here is the universal set. So that tells us the total number of pieces of data. So we do pay attention to that when we are doing the formula for probability. So it's probability of the event is the number of favourable over the number. So that's n for number, bracket, and that universal set symbol. So say I wanted to find the probability that a student selected at random is a Year 8 student. I would be doing the probability of Year 8 student is the number of favourable outcomes, which in this case, I will look at the bottom of that Year 8 column. I see that there are 160 chances that the student selected at random is a Year 8 student. And then I can also see that the universal set is 300. Now, I know both of those end in a 0, so I know for certain that I can divide them by 10, which will give me 16 over 30. I can also see that can be reduced further because they are both even. So I'll divide them by 2. 16 divided by 2 is 8, and 30 divided by 2 is 15. If I selected a student at random out of all of those 300 students, there's an 8 out of 15 chance that that student is a grade 8. Then again, if I were to calculate the probability that a student selected at random loves maths, I would do the same formula. So probability of event is the number of favourable outcomes over the number of items in that universal set. So probability that was loves maths. The probability of that, I'm going to look in the first row of data. So looking across loves maths, there are 120 Year 7s, 110 Year 8s, which gives me a total of 230. And my universal set is 300. So I know that out of those 300 students, 230 of them love maths. And I would have 230 chances to find a student who does love maths. Again, I can see that both of those numbers end in 0, so I can divide by 10, no worries, which leaves me with 23 over 30. I can't reduce that any further, so the likelihood that out of 300 students, I would randomly select a student who loves maths is 23 out of 30. If I wanted to calculate the probability that a Year 7 student who loves maths is selected, I would do, again, probability of event equals the number of favourable outcomes over the number of total items of data in the universal set. And I would say probability Year 7 who loves maths. So to calculate the probability that a Year 7 student who loves maths is selected out of all possible students, I'm doing again the probability of the event is the number of favourable outcomes over the number of items of data in the universal set, or the total. So probability, then my event is Year 7 who loves maths. I'm going to be looking at the intersection between loves maths and Year 7. So I can see that there are 120 Year 7 students who love maths, and my universal set is 300. Both of these end in 0, so I can reduce them to 12 over 30. There is a 6 out of 15 chance that out of those 300 students who are asked their feelings about maths, that I would find a Year 7 student who loves maths. To calculate the probability that a Year 8 student is selected given that they love maths, I would do this slightly differently. Notice the difference in phrasing there. I've said selected given that they love maths. So now I'm going to be using the total of loving maths as my total number because I'll only be selecting from students if they love maths. That's what that given that they love maths phrasing meant. I'm going to go the probability of, so I'm going to write exactly what I'm told, which is Year 8 given that they love maths. Now, you will be writing this a lot more neatly because you will have more space. So the first thing that I'm going to do, because it has changed from that 300, I'm going to look at what my universal data set is now, and that is, in purple, 230. And if I look across, in that same row, there are 110 Year 8 students, and that is in that green section, 110 who do love maths. And those are both divisible by 10, so I'll end up with 11 over 23. The probability of me selecting a Year 8 student, given that they love maths, which means choosing a Year 8 student out of everyone who does love maths, is 11 over 23. If I were to select a student who doesn't like maths, given that they are a Year 8 student, this tells me that given that they are a Year 8 student means that we're going to be using the Year 8 total as our universal set. So that is in orange there. This means that I'll be writing student doesn't like maths given they are a Year 8. So I know that there are, in my data set now, there are 160 at the bottom of that Year 8 column in the total section. Out of my Year 8s, I know I'll go up to does not love maths, and I find that 50 do not. Of course, I'm sure they're mistaken, but 50 out of 160 Year 8s say that they do not love maths. I can reduce this further because they're both divisible by 10. That gives me 5 over 16. So that is way less than half, which tells me that most people in grade 8 do love maths, and that I only have a 5 out of 16 chance of finding someone who does not love maths. Always just be clear on what the question is asking you. Make sure you use the information that you're given and the probability formula, and I think it will be quite straightforward once you learn to read the two-way tables to work out the probability for any given question.